Hello everyone, how are you guys doing? I hope you're all doing amazing. Welcome to another video, and today our problem is removing duplicates from sorted array 2. Now this is supposed to be a LeetCode medium problem, but I highly recommend that you watch the remove duplicates from sorted array video before going through this problem, because I think it is a natural extension to that problem. And if you have seen that video, if you understood that solution, this solution should come as a natural extension, and I'll try to build up a solution that follows as simply from the previous problem as possible. So let's read the problem now and try to understand how is it different from our previous problem. So you're given an integer array nums which is sorted in non-decreasing order, and you want to remove some duplicates in place such that each unique element appears at most twice. So previous time we were only supposed to return unique elements in our final updated array, but this time we have to update the array in a way so that each unique element is allowed at least twice, and you also want to return your final number of elements that will be in the nums that actually matter to us, ignoring the last few elements as we have been doing till this video. So that is your problem. So let's take up an example and went to straight through a whiteboard to actually solve the problem. So you have your nums array which is 0 0 1 1 1 2 3 3, and you want to update it so that each element occurs at most twice. So you are left with 0 0 1 1 2 3 3, and you don't care about the last few indices, and you also return the number of elements that will be there after this particular update. So let's see how we can deal with this. So if you remember the previous video, we will follow the same framework that we have been till now. So you define this kind of your array, you write down your output, which will look like, first of all, you return the number of elements, and you also return what your final array will look like after the updates. So this is what it looks like, and you don't care about the last two indices. So we discussed that in these kind of problems where you have to update the values in place, you mostly end up with a two-pointer approach where you first figure out your iterating pointer, which in this case will again be the same as our previous videos, where we want to go through the length of the whole array to actually see what all indices should be updated on it. So that should be pretty straightforward, where in this case it will be len array, and your helper variable needs to be something that tells you where do you want to update. Now in this case we want to fill in the first n elements, so therefore we are going to put our helper and start it at 0, and we are going to update it on the basis of a comparison with our another variable which is used to compare if the value is actually occurring more than twice or not, and how can we go about that. So if you remember our observation from the previous video, we know that it is a sorted array, and for any element to occur twice, it should occur just after its own iteration. Now for an element to occur more than twice, it should occur one index ahead of itself, so that what you basically want to compare is that if your element is equal to your previous to previous element, then you know that that is occurring more than twice. So in the previous case we used a previous variable which used to tell us that if it is occurring twice or not. Now in this case we need another variable which is previous to previous, which lags to with respect to our array. So let's see how we can find that. So you basically want to previously you had a variable previous which was instantiated somewhere around here to some value which is out of bounds to your array inputs, and this time around you need another variable which follows your previous, and that let's call it previous to previous, just to keep the explanation pretty straightforward. And it will also be instantiated somewhere out of the bounds, and it will be updated to previous, and it will follow the array with a lag of 2. Now that's your solution. That's basically what you want to do. So let's go back to our coding part. I know we have already discussed and done a dry run of the previous problem, so I don't want to waste any time doing that again. I think that should be pretty self-understood, and how we are maintaining a variable which is in lag 2 now instead of maintaining a variable which was at lag 1 the previous time. So what we're going to do is we're going to instantiate two variables, which is your previous and your previous to previous. And always read your questions carefully. And if you see here, you can see that your nums would be in range of 10 to the power 4 to 10 to the power minus 4. And what am I saying? Minus 10 to the power 4 to 10 to the power 4. So Therefore, your previous and previous to previous should be instantiated to something that is not in this range. So we are going to instantiate them at 1 lakh for now. So let's just do that. And you're going to also instantiate your helper function, or your helper variable, sorry, at 0 at the start of your iteration. And you basically want to do the same things you have been doing till now. You want to iterate your array. Only I can type properly again. Plus, and you basically want to check if your nums I is not equal to previous. And if that's the case, you want to override your helper uh, pointer with your nums I, and at the same time you want to increment your helper pointer. And no matter what's the case, whether your value is equal or not, you want to maintain your previous and previous to previous. So your previous to previous should be updated to previous, and your previous should be updated to nums I. Now the ordering matter here is to make sure that you first update your previous to previous and then you update your previous, because then your value will be maintained properly. Otherwise, you would be maintaining incorrect values and you will be facing an error. And at the end of it all, you want to return your helper. So that should be it. And let's just run this to see if everything is working or not. Cool. So it is working. Let's submit it to finally check. Drum rolls. Cool. So it is working and it is optimized 84.9, and the optimization rate
That you had you could
84.91% of people, which is fine, and the memory beats 57.80%. Now, in the previous video, the way we solved the memory problem was by, instead of using a variable here, using the indices directly to update our nums array. So you can look into that optimization yourself. I'm not going to waste time on that. One thing we can quickly observe and do here is the fact that, as we did in the previous video, we saw that updating our first variable doesn't ever make sense because it's always going to be unique in the sense. So we can always start from the second index. In the same way, in this problem, updating our first two variables never makes sense because our first two pointers will always be unique and they will never occur more than twice. So you want to start your update from here. So one thing we can do here that will quickly do some level of optimization, which is basically removing two iterations from our array, and that should save us something if anything. So your helper should start at 0, and if you start your loop at 0, in that way you're also going to update all of the values correctly because you never want to update your first two indices. So let's just run this again to check if everything is working or not. Wow, it's not working for this case. Why would that happen? Because previous to previous and previous are not maintained properly. So if you're starting your array at 2, you want to update your previous and previous to actual values. So your previous should be nums 1 and your previous to previous should be nums 0. In that way, you will be maintaining your previous's correctly so that you don't face an issue later. So let's just run this again. Everything should be working properly now. Cool, it is accepted. So let's just submit this just to see if the code is correct. Oh, we face a runtime error because the index is out of range. Okay. So yeah, that would be an edge case in this condition. So what we want to do is, if your len nums is less than equal to 2, you just want to return 2. You just want to return your len nums and you don't want to do any updates as well. So this should take care of that edge case. Let's submit again. Cool, now it's working and we don't see any improvement in the runtime. So I also don't trust this runtime calculation from LeetCode, but I don't know. It seems like optimization to us because you are taking care of the edge case here, and you are reducing 2 iterations from your loop each time. If you know any reason why LeetCode would be taking more time here, please let me know. And yeah, just try to explore the non-variable approach using indexes by yourself. That's a task for you. So that's all for this video. See you next time around. Bye bye.